We're going to look at different ways to simplify expressions that involve exponents. So we're going to look through some different rules. We're going to start with the product and quotient rule. Before we start with the rules, though, we should get some basic vocabulary. So when you have exponents, there's two pieces. There's the base and the exponent. So let's say we had 2/5. Then how we would describe this is 2 would be the base, and the 5 would be the exponent. So that's some terminology you'll hear come up. So let's start with the product rule. When we work with the product rule, what we're doing is multiplying. So the word product links to multiplication. So we're multiplying two pieces, and what's key is that they have the same base. So this only works if they have the same base. And what we can do is the product rule tells us that we can combine this into a single value with that same base. And then what we do with the exponents is we add them. So let's say we have x cubed times x squared. Then what we can do is make it a single value with the base of x, and then we add the exponents, 3 plus 2, so that would give us x to the 5th. So to see this kind of written out in long form and why this works is that if we're taking x cubed times x squared, if we wrote this out in long form, so x cubed is just the same thing as x times x times x, and then we're multiplying that with x squared, which is x times x. So really in the end, we have 5 of these x's multiplying to itself. So that would give us x to the 5th. It's just that when we start making these exponents larger, it can be difficult to visualize writing out all of those pieces, but in the end you just end up adding how many x's you have plus how many x's you have when you're multiplying them together. Our next rule is the quotient rule. So this is if we're dividing two pieces. So the word quotient links to division. And again, it's going to be key, they have the same base. So what you can do is combine them to that same base, and then we look at the difference between the exponents. Now it's key with this is that the order matters. So your first exponent that you'll use is coming from the numerator, and then you'll subtract the exponent from the denominator. So it always needs to go numerator minus denominator. So let's say we have x to the 5th divided by x cubed. So what we can do is combine that so we have that shared base of x, and then we'll take the exponent from the numerator, 5, minus the exponent from the denominator, 3. So 5 minus 3 would give us x squared. So in a similar way, let's think about why this works. If we have x to the 5th over x cubed, if we wrote this out, what this would look like is we'd have 5 x's multiplying to itself in the numerator divided by 3 x's multiplying to itself in the denominator. And what happens is cancellation, because this is all multiplication and division. So if you have shared factors between the numerator and denominator, you can cancel them out. So in this case, we'll be able to cancel out the x's that are in the numerator, and that'll leave us with just 2 left over. So that's where it becomes subtraction, is because there's going to be this cancellation. So however many you have in the numerator, you're taking away how many you have in the denominator. So again, I like to write those out so you can see where the rule is coming from. And also, if you happen to forget the rule, think about what would happen if you expanded these out, took them out of exponent form and just thought of them as a string of multiplication of the same thing over and over and over again. And the rules just summarize how those values would combine. So let's practice. So here's some cases where we're dealing with larger numbers. So in this first one, we have r to the 23rd power times r to the 15th power. So the key is that we are multiplying and then they have the same base. So what we can do is combine them and we would add the exponents together. So we take 23 plus 15, which should be a 38. So that would give us r to the 38th power. And again, you just think of, you'd have 23 r's multiplying with 15 r's. So overall, you'd have 38 r's. All right, quotient rule here. So we're dividing two pieces with the same base so we can combine them. And then we're going to look at the difference between the exponents. So we'll take 125 from the numerator minus 15 from the denominator. And that'll give us m to the 110 power. So again, these numbers are much larger, but it would come from, we have these 125 m's multiplying to themselves in the numerator, 15 in the denominator, and we'd end up with this cancellation. So that would be taking 15 away from what's in the numerator. And let's look at combining these rules together. So when we're dealing with division, you want to completely simplify your numerator and denominator first before dividing. So what I'm going to do is simplify that numerator first. So that would be using my product rule. So we'll take 32 plus 4 for that exponent in the numerator over, and then x to the 12th is all simplified. So in the numerator, we have x to the 36th power over x to the 12th. And that calculation will then use the quotient rule. So we'll have x and then 36 minus 12, which would give us a final exponent of 24 for our value of x. So that's our product and quotient rule for working with exponents.